This unit is all about looking at the 4 different types of market structures in which industries and firms compete. And every business in the United States is competing in one of 4 different market structures. It is competing in either perfect competition, monopoly, oligopoly, or monopolistic competition. And so in the next 3 modules, beginning with this one, we are going to look at the structure of perfect competition. And in this module, this will introduce you to the market structure of perfect competition and what it is. So in this module, we are going to determine the profit-maximizing quantity of output for a price-taking firm, and we will assess whether or not a competitive firm is actually profitable. In the last module of the last unit, we looked at the 4 different types of market structures that exist. And here you see them stretched out on a continuum. At one end we have perfect competition, at the other end we have monopoly, and then in between we have monopolistic competition, which combines elements of both, but is more like perfect competition, and oligopoly, which combines elements of both, which is more like monopoly. Perfect competition is unique in that it is the only market structure that is perfectly competitive. The other 3 types of market structures you can see are all classified as imperfect competition. And so characteristics of perfect competition are that there are many small firms, we usually say hundreds of small firms, although there could be thousands in the industry, each one with a market share so small that economists say their market share for each individual firm is 0% or very near 0. They all sell identical products that are perfectly substitutable for each other. There are low barriers to entry and exit from the industry, which means if profits are being made, it's easy for other firms to get into the industry to make profits, and if losses are incurred, it's easy for firms to get out of the industry to get rid of their losses. Sellers have no need to advertise because they're selling identical products all at the same price, so there's no way to gain more market share by doing that, and they can sell as much as they want at the market price, so there's no need to do it. And in this industry, we say that firms are price takers. Because they have such a small share of the market to themselves, they have no ability to set their own price. And so the market determines what price they have to accept. So we call them price takers. The seller has no control over the price under perfect competition. Examples typically include agricultural products. There are very few examples of perfect competition in the real world, very few. The only place we tend to find them is in the realm of agriculture, where you may have hundreds or thousands of farmers all growing an identical product, like corn or strawberries or milk, things like that. Now, why do we consider firms in the perfectly competitive market structure to be price takers? Well, when they charge the market price, let's assume this. Let's assume that a firm wants to charge a price above the market price. No one will buy it. Why? Why won't they buy it? Because their product is identical to everyone else's product that is charging a lower price. Why would you pay a higher price for something that is perfectly identical to something that is being sold at a lower price? So if a firm tries to charge a higher price above the market, no one will buy it. And what if they charge a lower price? You might say, well, they should charge a lower price. No, because consumers will buy just as much at the market price. Because they have such a small share of the market, they can sell as much as they want at the market price. So it would be crazy for them to charge a price lower than the market price, because they would only lose profit if they do it. They wouldn't gain any market share, and they wouldn't make more profit. So, because consumers will buy just as much at the market price. So they can't charge a higher price, and they have no reason to charge a lower price, which means they will charge the market price, and they're a price taker. So since the price is the same at all quantities demanded, the demand curve for each individual firm is perfectly elastic. It will be a horizontal straight line at the market price, because they can charge as much as they want, or they can sell as much as they want at the market price. So here we compare the industry demand curve under perfect competition with an individual firm's demand curve. And you need to understand both, because on the AP exam, they often have questions in the free response section that ask you to draw or compare the industry demand curve under perfect competition with an individual firm's demand curve. In the industry, all firms face a downward sloping demand curve, like we've already seen when we studied the law of supply and demand. So in the market as a whole, demand is downward sloping. When the price falls, the quantity demanded rises for all firms. When the price goes up, the quantity demanded falls for all firms. And they face an upward sloping supply curve. So the industry in this particular case would be accepting a market price of $10, and in the industry, 5,000 would be sold. But for the individual firm, they have to accept the market price of $10, and no matter what quantity they sell, they will be charging a price of $10. So the individual firm's demand curve is horizontal. It's perfectly elastic. No matter what quantity they sell, they will be charging a price of $10. They have no reason to charge a price above $10. They won't do that because they would sell nothing, as we said. And they have no reason to charge a price below $10 because they would lose profit. So they will always charge a price of $10, and they can sell any quantity they want at that price. So the perfectly competitive firm is a price taker, and it's set by the industry. So what is the additional revenue for selling an additional unit? Well, if you sell one unit, you earn $10. If you sell a second unit, you earn another $10. So marginal revenue will always be $10. So notice that total revenue increases at a constant rate. It always increases at a rate of $10 for each unit sold. So the marginal revenue will always be equal to the price. And if you look at total revenue and you divide it by the quantity sold, that will be equal to the average revenue, which is also equal to the price. We've also said that this is equal to the firm's demand curve, a perfectly horizontal elastic demand curve at the market price, and that is also equal to the price. So under perfect competition, and this will only be true under perfect competition, the marginal revenue curve will be the same or equal to the demand curve, which will also be equal to the firm's average revenue curve, which will also be equal to the price. And if you look at the acronym, you could spell that out as Mr. DARP. Mr. D-A-R-P. And if you remember that, if you remember and memorize Mr. DARP for the individual firm's curves under perfect competition, you will always remember that if you have to draw the marginal revenue curve, it will be perfectly horizontal at the market price. And if you have to draw the average revenue curve, it will be perfectly horizontal at the price. And if you have to draw the individual firm's demand curve, it will be a horizontal, perfectly elastic demand curve at the price. So all four curves are the same, perfectly horizontal at the price. And that's why we ask students to memorize that acronym, Mr. DARP, to draw any of these four curves for the perfectly competitive individual firm. But also remember that the industry demand curve is downward sloping, even though the demand curve for the individual firm is horizontal. So for perfect competition, the demand curve is equal to the marginal revenue curve. And that will maximize profit. So, in the short run, and in the long run too, what is the goal of every business? It's to maximize profit. And so when we look at a perfectly competitive firm in the short run, to maximize profits, firms have to make the right output decision. They have to decide how much of our good or service are we going to produce. So firms should continue to produce until the additional revenue from each new output equals the additional cost. So if we assume that the price is $10, should you produce if the additional cost of another unit is $5? Yes, you should. That's your marginal cost, right? But what's your marginal revenue? Well, marginal revenue is always equal to the price, and the price is $10. And you should always produce another unit if the marginal revenue is greater than the marginal cost. You maximize profit when marginal revenue is equal to marginal cost. So if the marginal revenue is always $10, we're going to continue producing until the marginal cost is equal to $10 or until it's greater than $10. So if the additional cost of another unit is $5, should we produce? Yes. If the additional cost of another unit is $9, should we produce? Yes. If the additional cost of another unit is $11, should we produce? No, because the marginal cost of $11 is greater than the marginal revenue of $10. So the profit maximizing rule in every market structure, including in perfect competition, will always be what we learned in the past unit. When marginal revenue is equal to marginal cost, profit is maximized. So you should always produce another unit as long as marginal revenue is greater than marginal cost. Once marginal cost is greater than marginal revenue, you stop producing. Profit is maximized when marginal revenue is equal to marginal cost. That is the profit maximizing rule. We learned it in the last unit. It's true in every industry, and you have to memorize it. So here's a tip for the AP exam. One of the most important concepts to learn in microeconomics is that firms maximize total profit by choosing the quantity of output that equates marginal revenue and marginal cost. You have to know it, know it, know it. So the price-taking firm's optimal output rule, or sometimes we call it the profit maximization rule, says that a price-taking firm's profit, and a perfectly competitive firm is a price-taking firm, its profit is maximized by producing the quantity of output at which the marginal cost of the last unit produced is equal to the market price. We learned that in the last unit. And the marginal revenue curve shows how marginal revenue varies as output varies. So suppose Melanie's Melons is a perfectly competitive producer of watermelons. The market price of each melon, you can see here, is $8. Her revenue and her short-run costs are presented in this table. Note that in this perfectly competitive firm, because the firm is a price taker, each time a melon is sold, total revenue rises by $8. Thus, the price is equal to the marginal revenue, which is equal to $8. So we know that Melanie should produce 5 melons. Why? Because that is where marginal revenue is equal to marginal cost, if you compare those two columns. How do we know this? Well, recall that we can tackle the decision to produce as step-by-step answers to a simple yes or no question. If we produce the next unit, will the additional dollars received in revenue, the marginal revenue, at least outweigh the additional dollars incurred in cost, marginal cost? If marginal revenue is greater than marginal cost, then we should produce that unit. If not, if marginal cost is greater than marginal revenue, we do not produce that unit. So, for the fourth unit, the marginal revenue equals $8 and the marginal cost is $6. Yes, produce the fourth unit. For the fifth unit, the marginal revenue equals $8 and the marginal cost equals $8, so they're equal, so yes, produce the fifth unit. But for the sixth unit, the marginal revenue is $8 and the marginal cost is $10, so no, we should not produce that unit. If we look at Jennifer and Jason's farm, we can see the same thing. And if we look at marginal revenue here, it's $18. So where do we produce? We produce up until the fifth unit. Because with the sixth unit, the marginal cost of 20 is greater than the marginal revenue of 18. But at the fifth unit, the marginal revenue of 18 is greater than the marginal revenue of 16, so we should produce 5 units. So we can see this in this graph where the horizontal price, which is equal to marginal revenue, which is equal to the demand curve, which is equal to average revenue, that horizontal curve intersects the upward sloping Nike swoosh marginal cost curve at a quantity of 5 melons. So that is where marginal revenue is equal to marginal cost under perfect competition. So you draw the marginal revenue curve, which is Mr. DARP. It's equal to the price, equal to the marginal revenue, equal to the perfectly elastic demand curve, equal to average revenue. You draw your Nike swoosh marginal cost curve, and where the two intersect, that is the profit maximizing quantity of output, in this case 5. And you may be asked to draw a graph like this for perfect competition on the AP exam in question number 1. In question number 1, it's always a long response question, and they either give you a graph, and sometimes it's a graph of perfect competition or monopoly, or they ask you to draw a graph like this for perfect competition or monopoly. So you have to know how to do this and how to show it and label it and show everything on it properly. So there are two things that we should notice about this curve. And let me go back to the previous screen. First of all, average revenue is equal to total revenue divided by the quantity. When the firm is a price taker, average revenue is equal to price times quantity divided by quantity, which will be equal to the price. In this example, we can see that on average, each melon that Melanie sold earns her a price of $8. Because the firm cannot raise or lower the price, the horizontal price equals the marginal revenue curve, which equals the average revenue curve, and that also serves as the perfectly elastic individual demand curve for Melanie's product. A horizontal demand curve was described in an earlier module as being perfectly elastic. So Melanie should produce a quantity of 5 melons, but a more basic question should also be asked: is she earning any economic profit? And if not, is it wiser to not produce any melons at all? To answer these related questions, we first need to see again how profit is calculated. Remember that economic profit is equal to total revenue minus total cost. So looking at this simple equation, we can see that if total revenue is greater than total cost, economic profit is greater than 0 and positive. If total revenue is less than total cost, then economic profit is less than 0 and therefore it's negative. If total revenue equals total cost, then economic profit is equal to 0, and we say this is a normal profit. So going back to the previous table, this one here, we can see at a quantity of 5, total revenue is greater than total cost. And economic profit is equal to 40 minus 30, which is equal to $10. So economic profit is positive at a quantity of 5. Another very useful way to determine if profits are positive or negative is to look at profit on a per unit basis. So again, remember that total revenue minus total cost equals profit. And to see this on a per unit basis, we divide the profit equation by the number of units, or quantity. So profit divided by quantity equals total revenue divided by quantity minus total cost divided by quantity. This tells us that profit per unit is equal to revenue per unit minus cost per unit. So there are two substitutions that we can now make. Revenue per unit is equal to average revenue, which is equal to the price. And cost per unit is equal to average total cost. So when we make these substitutions one last time, we can say profit divided by quantity, or the average profit, is equal to the price minus average total cost. So looking at this simple equation, we can see that if the price is greater than the average total cost, economic profit must be greater than 0 and therefore profit. positive. If the price is less than average total cost, then economic profit must be less than 0 and therefore negative. If profit is equal to average total cost, then economic profit must be 0. And remember, if economic profit is positive, greater than 0, or equal to 0, a normal profit, then this represents the best use of our resources. And there is nothing else we could be doing to make greater economic profit. But if profit is less than 0 and negative, then this is not the best use of our economic resources, and there is something else we could be doing to make more economic profit. So let's take a look at a modified version of the table that we just looked at. Okay. We can see from this table that at quantity of 5, price is greater than average total cost. So profits, we know now, are positive. Profit per unit is equal to profit divided by quantity, which is equal to the price minus average total cost. So that's $8 minus $6, which equals an economic profit of $2 per unit. So since a quantity of 5 units were produced, total profit is equal to $2 times those 5 units produced, which would equal $10. We can also add the average total cost column of data to the first graph. So now, when we draw the average total cost column and draw it into the first graph, what can we see here? Well, we can see there are a couple of things. That at that price, where average total cost, where marginal revenue crosses marginal cost, if we drop down to average total cost, we can see what our profit is going to be. And that's something we'll be looking at in the next module. So once again, here we see the price-taking firm's profit maximizing quantity of output. We have the horizontal perfectly elastic demand curve, Mr. DARP, marginal revenue equal to average revenue equal to the perfectly elastic demand curve equal to the price, crossing the Nike swoosh marginal cost curve, and where the two intersect is where marginal revenue equals marginal cost for the perfectly competitive firm, and that's its profit maximizing quantity of output, which here would be at a price of $18 and a quantity of 5. So now let's put cost and revenue together to calculate profit. Here we see side by side the industry demand curve, which is downward sloping, with the individual firm's demand curve, which under perfect competition is perfectly elastic. We've also drawn in the firm's average total cost curve and its marginal cost curve. So how much output should be produced? How much is total revenue? How much is total cost? And is there profit or loss? And how much? Well, we can see in this example, the marginal revenue curve intersects the marginal cost curve at a quantity of 9 and at a price of $7. So we take that point, but now we have to figure out, okay, that our marginal revenue is $7, that's the price, but how much does it cost us to produce this? We have to subtract our cost from our revenue to determine profit. So from that point where marginal revenue intersects marginal cost, we draw a dotted line down to where we intersect the average total cost curve. And from over there, we draw a line over to see that our average total cost of production is $5. So now we subtract our revenue, marginal revenue of $7 from our cost of $5, and 7 minus 5 is 2. We multiply it by the quantity that we sold, which is 9, and that gives us a total profit of $18, which is the green shaded area. And it's very common for you to have to draw a graph like this and to shade the area of profit. So to do that, go to the point where marginal revenue equals marginal cost, draw a line down to the average total cost curve, then draw a horizontal line over to the y-axis. That's your cost. Subtract it from your price, and then multiply it by the number of units you sell, and shade that rectangle. That's your area of profit. And what is if they ask you to compute total cost? Well, total cost is going to be the area of the rectangle going from the average total cost point down to the quantity and multiply the area of that square. So it will be 5 times 9, which would be $45. So notice that for a perfectly competitive firm, the horizontal line at the market price also represents the marginal revenue curve and the demand curve. You have to be prepared to draw and label this line for the AP exam. So make sure you know how to do it. Study this graph. Now, suppose the market demand falls. What would happen if the price is lowered from $7 to $5? Well, the MR equals MC rule still applies, but now the firm will make an economic loss. The profit maximizing rule is also the loss minimizing rule. And so here, how much output should be produced? How much is total revenue? How much is total cost? Is there profit or loss? How much? Well, notice in this example, when we go to the point where marginal revenue equals marginal cost at a price of $5 and a quantity of 7, notice that instead of the average total cost curve being below the marginal revenue curve, it's above the marginal revenue curve at that point. If average total cost is below marginal revenue, that means we're making economic profit. But if average total cost is above marginal revenue, then we know we are actually making an economic loss. Well, how do we calculate it? Well, now we draw a line up to the average total cost curve and a horizontal line over there, and that's a cost of $6 minus the price of 5, so that's 1 times the number of units sold, $7. We shade that area, and that is the area of economic loss. Then we go down to the marginal revenue curve where it intersects marginal cost, and over to the price, and then down to the remaining area, shade that area, and that's our total cost. So our total cost is $42, but we're losing $7. And so here there's economic loss, and you may have to draw this kind of a curve and show the area of economic loss as well. So when is production profitable? Well, if total revenue is greater than total cost, the firm is profitable. If total revenue equals total cost, the firm breaks even. If total revenue is less than total cost, the firm incurs an economic loss. Now, remember, at times, the marginal revenue at a given output may be greater than the marginal cost. This is preferable to a firm if the next unit creates a marginal revenue that is less than the marginal cost. They don't have to equal, but is close to equal without the marginal revenue being less than the marginal cost. Here you see short-run average cost for Jennifer and Jason's farm. Again, it looks much like what we've seen before. You may want to pause it and study it if you need some more experimenting with that. Here is a video that you can go to the ACDC Econ website and look for the video entitled Perfect Competition in the Short Run and listen to Mr. Clifford and his review of the industry demand curve under perfect competition compared with the individual firm's demand curve. And I would recommend that you do this. Here is an activity that we will work on in class to practice perfect competition in the short run. Here is another chart that shows you from Jennifer and Jason's farm. This just shows the marginal revenue and average revenue, price and demand curve intersecting the marginal cost curve. It shows that their market price will be $14 and their profit maximizing quantity of output will be equal to 4. and you can see the average total cost curve intersects those two curves at the exact same point, which tells you that economic profit is not at a loss, it's not a profit, it's equal to zero. So this would be a normal profit for Jennifer and Jason in the short run. So the break-even price of a price-taking firm is the market price at which it earns zero economic profits, as we just saw with Jennifer and Jason's farm in the last graph. Whenever market price exceeds average total cost, the producer is earning economic profits and is profitable. Whenever the market price equals minimum average total cost, the producer is breaking even and earning a normal profit. Whenever market price is less than minimum average total cost, the producer is earning an economic loss and is unprofitable. You can go to the ACDC Econ website and do a practice question. It's entitled Micro Unit 3, Question 11. That will give you some practice with it if you desire to do so. Here is another activity that we'll work on in class, Perfect Competition Basics. Here's another activity we'll do in class to practice graphing perfect competition. And here is a summary of what we've learned in this module on our Introduction to Perfect Competition. This ends our look at Module 58, Introduction to Perfect Competition.